Okay, so in this chapter, we'll look at how fossil fuels are formed, how do we get them, and how do we use them. So here are the learning objectives. We'll look at the properties of fossil fuels, that should be fuels, availability of fossil fuels, um, application of the Hubert model, and so on. Okay, so fossil fuels originate from ancient organic matter, plant and animal matter. That has, as you'll see, that has been buried in rocks and subject to high temperature and pressure. And fossil fuels are formed over hundreds of millions of years. So we'll look at some of the details. So depending on the details of the starting material, the fossil fuel can be solid coal. Coal is from mostly plants, trees, and stuff like that. Liquid or natural gas. Oil and natural gas are mostly formed from animal matter, well, algae and plankton as well. Okay, so this is the starting material, something called kerogen, and let's look at how kerogen is formed. All organisms are dying. Organisms are dying all the time. So when they die, they decay, and almost all parts are recycled and reused by the biosphere. However, a small fraction, 1% of the dying biomass, sediments. What this means is the plant or animal dies and form falls to the bottom of a lake or an ocean, and then you have sediment, sand particles, and all that overlay on it, and under pressure that becomes a rock, a sedimentary rock. Okay, so this is the process of sedimentation. That is, it included in the forming of rocks or mineral layers of sedimentary origin. All sedimentary rocks include a more or less important fraction of organic matter, around 1% of organic matter. So that was trapped during the forming process. This organic fraction undergoes a transformation due to bacterial activity, and that the bacteria transform that organic matter into a solid compound which is named kerogen. It's not a single compound, it's a complex combination of compounds, but it's a solid matter and that's called kerogen. And coal and oil and gas are formed from kerogen. So kerogen is solid, insoluble organic matter in sedimentary rocks. And the total kerogen on Earth is about 10 to the power of 16 tons. It has 10 to the power of 16 tons of carbon. So that's how much carbon is trapped into kerogen on the planet today. And this amount of it is the most abundant source of organic compounds on Earth, exceeding the total organic content of living matter by 10,000 folds. So there's more carbon in kerogen, 10,000 times more carbon in kerogen than in all living matter today. Okay. Now this I have a link to a Wikipedia page, and you might want to read that. Now upon heating kerogen,